This diagram illustrates the essential difference between additive mixture and another process usually called subtractive mixture or mixing. Suppose we have two spotlights that emit light whose long or reddish, middle or greenish, and short or bluish wavelength components are balanced in the ratio that we perceive as white light. And suppose we also have one filter that transmits all of the long, half of the middle, and none of the short wavelength component, and another filter that transmits none of the long, half of the middle, and all of the short wavelength component. From what we've already said, you can infer that these filters will appear orange, yellow, and cyan blue respectively. If we mix light beams that have passed separately through these two filters, the mixture will have the same wavelength balance as the original spotlights and so will appear white. This is an example of additive mixture of lights. But if we now superimpose the two filters in front of one spotlight so that both filters remove wavelength components from the same light, we get a very different process called subtractive mixture. As before, the orange-yellow filter removes none of the long, half of the middle, and all of the short wavelength component, but now the cyan-blue filter removes all of the long and another half of the middle wavelength component of the light that came through the orange-yellow filter. The cyan-blue filter would transmit all of the short wavelength component, but this has already been removed by the orange-yellow filter. So the net result is that what gets through is only the middle wavelength or green appearing component, the only component partly transmitted by both filters at a quarter of the intensity in the original light. So in additive mixture of two lights, all of the spectral components present in either light make it into the mixture, while in subtractive combination of two filters or two paints, only the spectral components transmitted in common by both filters or paints survive. And notice also that using the same orange, yellow and cyan blue filters, we obtained a white light by an additive process and a coloured green light by a subtractive process. This result will be perplexing if we assume that colour is colour and so-called mixing of the same colours should give the same coloured results. But as we've said already, colours like orange, yellow and cyan blue are our mental perceptions of the spectral properties of lights and objects, including filters and paints. And it should really come as no surprise that combining the same coloured lights, filters or paints by different physical processes can yield different spectral results that we perceive as different colours. Whether we're mixing coloured lights or superimposing coloured filters or mixing coloured paints, it's not the colours that are mixing.